Um, I spent some time last night looking through some of the assignments, and I want to make a few comments to hopefully correct some um, misconceptions about some of the patterns. So the mental pattern, right? There's two parts to it. In one part, you're saving the state of that object so you can, maybe reinstate that state later. The other part is without violating the encapsulation part, right? And so the goal is if the object that you're going to say the state has private fields, then they're private, right? And without violent encapsulation means we then don't want to make that state public, right? So who can make the memento?
Object. Memento has access to information.
Right, so it's the class that creates the memento is the class you want to create the memento of, right?
So you're saying that turtle momentum
No. What I'm saying is if someone besides the turtle creates the memento of a turtle, then it's like that means that something can grab all the fields, right, of the turtle.
But it doesn't necessarily momentum.
Yes, the memento can be a separate class, and then we get things like I came across things like this where we've got a memento class, but the fields are all public. Oh, that's another way you can violate encapsulation, right?
Gotcha.
Right. So part of this pattern, right, is we're trying to keep that state hidden, right? And so then who can create it? Well, the turtle creates it because they're the one that have access to that state. If we let someone else create it, somehow they need to get the state, right? And then if you make it public, it's like the visitor pattern, right? Um, again, it's without changing the classes of the elements of that structure, right? So in the assignment, you had to create two visitors, right? One was just a distance, and one was creating all the mementos, right? It would be easier to modify the structure to do that, right? To create the distance, to compute the distance, add another method called, distance traveled in your structure would be easier, right? Each one you do it, and then the only one that ever returns something is a move, and then it probably gets all the way back up, and you compute the sum, and we're done, right? It'd be easier than doing the visitor, right? But the goal of visitors is, look, if we do it for for the distance one, then we have the memento thing, and then we want some other crazy other operation, all of a sudden our expression tree gets really, really messy and horrible. We're doing 15 different things because as time goes on, we want more and more things done, and none of us are related, but we just need it for this other thing over here. And so the goal is, we want the minimal changes to our structure. And the minimal changes are accept and visit, right? Oh, all of a sudden, if my turn expression knows about mementos, that means we've modified our structure to, to know about mementos. And so it's like, wait, the whole reason for visitor is not to add that stuff to the structure, right? We do accept, and then we visit there, and we might have to give the visitor some special privilege to interact with elements, right? But once we do this, that means we have to modify our structure for the visitor to work. And once you do it for that visitor, then you end up doing other visitors, right? And that violates what we're trying to do with the visitor pattern. Yeah, I mean, there's basically now the turn expression has to know about mementos. Well, but the turn expression has to know about turtles anyway, right? Because,
At some point,
yeah. This one, right? They created a whole expression tree and said, okay, I'm going to give it the turtle beginning. And it works, right? Because you create the turtle object, then you create your tree, and then but as you create the tree, you just give everything the turtle. Yeah, you only give it once, right? If we do it this way, right? Then we can, if we really wanted to, I could create 4 different turtles and put them in different places on the screen, and then run the same program on them. And so maybe I get a flower program, right? And now I can do 4 turtles, and they all start at different spots, and they go, right? So we get more flexibility without hardly any effort, right? Yeah. No, no, no. Well, I don't want you. Yeah, no, you create one program, right? But then when you say evaluate, you just pass in the turtle, right? But if you do it this way, we can have, yeah. And I still don't understand why people wanted to make all the variables constants and then have the parser basically optimize out all your variables. What's that?
you mean
I mean, well, it's not dollar sign, it's pound, right? K equals 10, and then we do move pound K, right? So then what they want to do is they want to say, oh, but I know K is 10, so now what I can do is I've got my program, and then I got my move, and then I can put 10 there, right?
without we also built it. So
But then the problem becomes, what do you do? And now I say, now K equals 15, and then I say move K
like, how
again.
does that handle reassignment?
Yeah. And some people have this complicated thing where your contacts should keep track of each variable could have different levels. And then you keep track of where that level was and what the values were at that different level. And it's like, well, if you just had an assignment statement here, right? K is equal to 10, and then K is equal to 15.
Since you're passing the content anyway.
Yeah, you just pass the contacts in with the evaluate, and then when you hit this, you say, okay, now K is 10. And then when you come here, right, you have your variable K, and you pass the context in, and it says, give me the value of K, and there's 10, and now I come here, and the context, it just says, okay, change the value in the context of k to 15, and so now when I do move again, pound k, again, you ask the context what's the value of k, and it's changed.
Just whenever you have
an
assignment, you put it in the tree just like everything else.
Right, right, exactly, yeah. Some people were doing, like I said, it's like, oh, it's a 10, so I can now I get rid of this. I now make this 10. So I get rid of this, and I get rid of this, and now I need to figure out how to make that 15. And you do that in the parser. Right. It's more work. And some of you probably recall this discussion on the wiki where like, can variables change values? I go, yeah, the variables. So of course I can change values. And they, no, but can it really change? And yes, I can actually, because they were trying to hard code these values in the parser, right?
Parser would just take the text file, rearrange the information in it into something that the interpreter can deal with. That's kind of
the parser was, yeah, just take the text representation and produce a object or representation of that program, right? So that's the things I just wanted to try and clear up before Tuesday.
so
What's that?
really good.
Well, I mean,
I'm going to see another don't panic
slide. This is just a misunderstanding of the pattern, right? And it's like,
we're just trying to gauge, like, okay, how good or yeah. You're seeing like dedicating a talk to the
I only sampled a few. I didn't have time to actually grade all of them. That would have been nice to be able to turn them back today, but I usually keep it in the language that I find it in.
Add a function using extension.
Well, extensions basically are adding methods to the class, right? Now, if you add methods just to expose the state so you can access it, you are making things which prior could not be accessed outside the class and now can be, right? Now, what does happen, different language features do impact the patterns differently. And like I said several times, as we go forward in time, right, more and more languages are coming out with different features. And so the Gang of Four book was written, and it came out about the same time Java did. but they were both being developed at the same time, right? Java was written, it took about 2 or 3 years before they released it. They were developing it at the same time. The ideas of design patterns were prevalent, right, in the community, so they knew about each other, right? Although the book couldn't use Java because Java wasn't out when they were writing it. But that was, I mean, some of you probably weren't even born then, right? That was, the book came out in 1995. And so languages have progressed um, since then.
This is actually, I thought of a while. Do you write these assignments with a specific language in mind? Because I feel like some of the problems, some of the problems that we're trying to solve, strongly suggest Java or something. But I'm wondering, now that you mentioned that the book was written with Java in mind, is that a byproduct of the book, or is that you, or is it a mixture?
There are some people that complain that the patterns in the Gang of Four book and many other patterns are just a reflection of the feature of the language at the time. And so they say that, I mean, they even go further and say, well, it's just a description of the defects of that language. Right, how to get around the defects of the language, right. So I've taught this course many, many times, and throughout, usually I allow students, some options, but nearly all the students most of the time are using Java, right? So that becomes, and the Python, the first time I allowed Python, and that Python has its own quirks, right? And Swift has, features other languages don't have, right? And so
It just seems like there are like a great deal of problems with Python than this book apparently addresses. And that's not to say that the patterns in Python, it's just saying there are probably very thick Python patterns address the efficient, the perceived. Exactly. And there's probably design patterns.
well, but if I posted, on the reading assignment, a link to a online Python book that does talk about some of these design patterns in Python. But basically, all they do is they just take the standard Gang of Four description and translate it into Python. And it's, most people do that, but you like Swift, right? We could question whether we need the visitor pattern in Swift, right? The whole reason, right, for the visitor pattern, we don't want to muck up that system of classes with all these functionality. But if I can do it over here as an extension, right, and then other people don't have to use my extension, do I need the visitor pattern, right? The need for it is much less because I can create my own extensions for my own project for those classes to do what I want, and no one else has to use them, right? And I don't have to edit those classes. I don't even need the source code for those classes. If I just have the binaries, I can still do it, right? So all of a sudden, do we need the visitor pattern in Swift? Like I said, it's going to be easier, right, to compute that distance by doing it directly on the tree, right? It's less work. And I don't even need the accept method on the visitor, right? I just write my own extensions. Okay, question. Don't have. Right, so I haven't been able to find time to, but if you go to previous course offerings of this class, right, I have a long list of previous exams. Right, and so there's, as you saw, there was 1, 2, 3, 4, 5, 6, 7. I mean, there's about 10 years worth of old exams. It give you an idea of what type of questions I ask, how often they change, or how often I change the format. Okay. So there was an announcement. Normally, what I do in this class is for the object coupling and cohesion. I put a cal copy and I put in the library, and cal copy usually each year they just keep it, but apparently they got rid of it. So there's a copy over there now. I did put it in the library, and they send it back and saying, no, this violates copyright rules. And I go, that's interesting because I've taught this course, 15 times, and each time I bring it over there. But the answer was, well, I look at the book and I look at how much, and the rules say that you can only go up to 10% of the book. And apparently this chapter is more than 10% of the textbook or the book, and so it violates copyright rules. Yeah, whatever patterns we've covered, right. Um, the literature lists as a separate pattern, but I'm not going to ask you how many design patterns have we covered, right? I mean, yeah, yeah, yeah. I mean, so what happens is um, usually the first assignment I give drives which patterns I'm going to talk about. Um, so in the past, commonly the first time, like, do a linked list, right? Do a linked list that holds students, and you then want to rank them by this or that. And then there are some patterns which makes sense there. Where, okay, there's a null object pattern which we can then illustrate in the linked list, but it doesn't make sense in the priority queue.
So in that case, because I know that like
Have we covered the null object pattern yet?
you sneak it in there, it's like, oh yeah, wait a second. Sneaky way to get these points. It's right now.
I mean, so we covered each year. The order of the patterns changes. Yeah, basically saying that this pattern I'm talking about relates to that pattern. That's it. But we haven't talked about the flyway pattern, right? Well, it's not the case that I'm going to, in half of a slide, cover a pattern and sort of sneak it by you guys. Like,
So then building off that, so we should then focus on strategy, interpret, command.
that we covered a certain number of patterns in class, and we covered a subset in assignments, right? Yeah, yeah, right. Yeah, yeah. I mean, now the final, we'll get them all. Did you read the big ball of mud paper?
The beginning of the semester. Like, seriously, that like 8 weeks before the class started.
But that is material we covered, right, in class, and so that material is fair top for the game. We talked about refactoring, didn't we? So shearing layers, right? What does that mean? What does that sound like it means?
Shear peel. Exactly. Shearing. Shears.
And so what does shearing layers refer to?
Getting to the center.
Now, what do they mean in the pattern? Yeah, we put them in different layers, right? And so there, the idea of shearing is like, oh, we have things change at different rates, right? And so things that change a lot are in one layer, things slower and slower. So, and the shearing comes in, what happens in between, right? When you got things changing fast and some changing slow, you get that. That's the analogy.
It seems like, at least from the questions that I've looked at so far, seems like in general you're looking for a solid understanding of what problems each pattern is intended to address and impacts those patterns. If we can have like a reasonably substantive understanding of those 3 points on each of the patterns that we covered, all 8 of them, the sharing layers, would you say that we're probably well prepared for what?
I would modify that, not saying shearing layer, but the big ball of mud paper.
Okay.
Right.
But otherwise, yeah.
Yeah, I mean, basically, when we look at patterns, what's important? First of all, you have to know why you want to use this pattern, right? And what, I mean, it has good impacts and bad impacts, right? So why we want to use it, what type of things, problems it solve, what problems it create, right? The next layer is, now that I know I want to use the flyweight pattern, what is it, right?
And then what's like the cost going to be associated with using it? Like,
right.
you're solving something, you're causing another. Like is the net a positive or negative?
Right. There's the consequences, right? So the pattern descriptions always have, an intent and a motivation and a consequences and a structure. Um,
Everything, every single.
yeah, and also I forget whether it's chapter 1 or chapter 2 of the book. They do have um, you know problems that we want to reduce coupling. Here's a bunch of patterns, right? That makes sense. Um, and I think that's also useful in the sense of, like I said, you want to know when should I apply a particular pattern, but usually it goes the other way around. I got a problem. Now, which pattern do I select, right? And so, then what drives it is, okay, I got problem X. What patterns are useful in solving problem X, right? So that's why that list and that chapter, I think, is sort of important, because it's one thing to memorize, the visitor pattern, blah, 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 but the way you actually want to access information is, I have problem X. Now, what are my options?
This was also, remember, we're talking about how I was trying to find the slide.
So the two major design principles that lie behind design patterns, one is program to interface, program to interface, right? And again, we saw that, right? So interpreter pattern, you create this interface that each of the elements in the structure implements, and then inside each one, we may have a collection or a thing that points to the next one, but we don't know which one it is, right? We don't care. It's like, just evaluate, right? Or it's accept turtle, right? Or accept visitor, and we don't know what that visitor does. All we know is we're going to call visit me on it, right? Um, so that's examples of programming to an interface, right? The second one is favor composition over inheritance. Composition over inheritance. And they actually came across an article this morning. It's actually a really long blog post in reaction to another blog post. Another blog post says, it's terrible. You should never use it in game programming. And then they gave it a simple old example of what, and it was like really slow and ugly and terrible. And this guy said, yeah, you gave a really bad example in old programming and you made it very inefficient. And then you gave it a non-O implementation, which is fast and efficient. Like, that's not fair. And he says, yeah, OO means, and he says, one of the things is you rarely want to use inheritance, right? It's just awkward and it's inconvenient and we always use it for the wrong reasons. Um, and he's like, yeah, you almost always want to use composition.
You said that like we're building it way.
Well, what do we get when you use composition is that we get flexibility. For example, right, the strategy pattern. Instead of creating subclasses to, sort students by red ID and sort by this, no, we just pass in a strategy, and now, right, at runtime we can change that structure. Same thing with a state pattern, right? We could create subclasses to represent that object operating in different states, but then how do you go from one object to the other? Well, composition just makes it easy.
It seems like composition makes like the distinctions between classes and specifically abstraction Like that's the point, right? Your class is to be related to themselves, for lack of a better term, and you achieve that. Because would you say it's yeah, you'd consider inheritance a type of coupling, wouldn't you?
Yeah, I mean, when you subclass things, you have to know how that thing works, right?
Yeah. And then it's probably not often, but when you change stuff about the parent class, it could like screw with things with kids, right?
Right. And vice versa, right? The kids can override things and break parent code.
Yeah.
So those are and we start looking at, you start seeing it, programmed interface. Well, iterator, right? In Java, there's an iterator interface, right? And so when you say, give me the iterator, you have no idea what it is. You have no idea what the concrete type is. All you know is the iterator face, I can call has next and next on it. Yeah. Now, don't you care? But it's better that you don't know, because if you did know, then you might say, declare your iterator to be type link list iterator, right? Equals list, give me the iterator. And now when you want to change that structure to be not a linked list, but array list, right? You're dead, because you've now hard coded that linked list iterator class outside of it. So we don't. So programmed interface makes things more flexible, because all you know is it implements this interface, and now we can change the implementation of that class. We have a different class, right, that has this implements the same interface and use it, right? And the iterator is a good example, because every time you get an iterator from one collection class, each one is a different concrete implementation of that interface. But we don't know, and so our code doesn't have to. I can write a function or a method that has an argument of type iterator, and we're not tied to, it's an array list iterator or a linked list iterator or a priority queue iterator. It's just an iterator, and it works. I'm done, right? And as soon as I say have that function an argument of type priority queue iterator, you've just greatly restricted what you can do. Can I give examples of coupling and cohesion? Well, coupling is just one class knowing about the other class, right? Interacting with it. So turn expression is now coupled to memento, right? No, no. You're in Java, the array list class and the string class are completely unrelated, right? There's no interaction between them. So there's no coupling between them. What's that? Say that again? Well, but you have to keep in mind that if we have a class in our project which has no coupling to anything, just get rid of it. And the program still works, right?
So loosely,
Yeah.
each class, they're separate classes. That class.
Yeah, so here, now the question is, how coupled is turn expression to the memento, right? Now, if all it does inside it says return turtle dot memento, It's just tied to the turtle class by calling that memento, and it's tied to memento but just don't exist, right? Now, if we start calling methods on the memento inside my turn expression, it becomes more coupled because now instead of just knowing it exists and it comes out of a turtle, we know that it has these various methods, right? So that becomes tighter coupled. Now, another example is, right, again, in our visitor pattern, right, our expression is pretty lightly coupled to the visitor. All it should know is there is a visitor interface, and I then have an accept method on it, and then I call visit on it. That's all I know. But the visitor is highly coupled to, right, in this case, our expression tree, right? Because it has to know all the different classes. It has to know, oh, when I go to the move, here's what I have to do, right? And when I go to the turn, that's what I do. And here's when I go to the repeat, this is what I have to do. So the visitor is tightly coupled to the structure it visits, but the structure it visits is loosely coupled to the turtle, right? And that's a more common situation, right? Where no, it's remember the whole point is we want to add more functionality to that structure, and how can you do that without knowing about the structure, right? But part of my complaint here was that the operation that we have the visitor do bled into the structure, right? And so now we're getting this sort of implicit, right? Our structure now implicitly knows about what the visitor is supposed to be doing. But like I said, we can't get rid of coupling altogether because the program is built to work to accomplish a task. And like I said, if the class doesn't couple to anything, just throw it away, and we got less code and we got the same functionality. And so the question is, what type of coupling? And often, yeah, we have this sort of dual situation where something we want to be lightly coupled, the expression, but then the turtle or the visitor becomes tightly coupled to everything. Oh, cohesion. What does the mementos have to do with turn? What? But why? I mean, what does turn do? What's the point of a turn operation? Change the state, right? So change the state. Why does it have to? Why does it have to know about Mentos? Why does it have to know about how computing the total distance travels, right? So cohesion basically says when we look at a function or look at a class, what is its task it's trying to accomplish, and how well do the things we put in there fit into that task, right? Another example is priority queue. Printing out students in a priority queue is like, does that make sense? Not really, right? So that putting a method called print student in a priority queue makes that class less cohesive. You got things that really don't make a lot of sense in a priority queue. Okay, so
we saw in your example here, we had a discussion about this. Is the pattern efficient? So we debated design patterns, not necessarily optimal.
So some languages have a repeat statement, right? Right, and you've got a block and some X, right? In a language like Java or C# or C++, when you compile this, what does it do? No, the compiler. When I compile it.
Oh, it translates. It does it 5 times.
But how does it do it 5 times? Well, if it optimizing might unroll a loop, right? So that might happen, but in general, what happens? We go to the assembly level, right? And assembly level, we have a jump, right? That's very efficient, right? It's assembly level saying, do this, do this, do this, and then in the bottom, we jump up back up here again, right? We do this, there's basically an if statement at the bottom, if, and we have a counter, and so it's very efficient, right? But in the interpreter pattern, what do you got? We have so in one case, in C, we're talking about assembly level instructions, right? In your class, you got a object, right? And then you got probably a while loop, right? Well, X is greater than K, right? Or less than K. And then we're going to evaluate that. And how do when we evaluate this expression, what are we doing? We're calling evaluate an object, right? And so we have to call a message to an object, and then we go inside that message, and then what do we do? If it's move, we would then call a method on turtle, right?
Because you're abstracting.
There's so many layers, and right? I mean, each one of these things is a message send before we do any work, right? And if we were in C, that would be all compiled down to assembly code, doing those operations directly. So interpreter pattern, right, is never going to be as efficient as compiled code, right? And you as a Python person really have to know this, right? Because no, Python itself is not compiled down to C. It's interpreted. And so when you got a for loop in Python, oh man, you just took a big hit. Why? Because in the for loop, it's like, oh, I have to evaluate this each time I come across that for loop. Every time I go, right, I evaluate over and over again, and all these things, oh, you think this is a number? No, it's not a number. Where numbers go? I mean, the variables are stored on the heap, right? And so you have to go follow a pointer, and it's crazy inefficient. Now, pandas, right, and all the scientific computing, it's all written in C. And so you're just calling C code. But the Python itself is very inefficient. Because it's interpreted, right? Yeah, it's still inefficient because you're not assembly code, yeah. Any other questions?
Squeeze that one in. But the way that since you did that grammar, it doesn't make that's or
Yeah, how do you extend the grammar? You add another grammar rule, right? And then each rule represents a class, right? And then that when you instantiate that, go in your tree someplace. So, yeah. What's that? and using programmed interface, right? Because everything is an expression, right?
So the reading from some steps conditions to do so. For question,
Yeah, I'm not going to ask you to repeat the small little steps the book talks about, right? Because I mean, it's
pattern and how do we which pattern we should use.
yeah, the structure is the same, right? Um, so what are the differences, right? One expects that objects will change their state frequently, right? Whereas the strategy, um, usually it's, I mean, you might change it, but usually you don't, right? I mean, I want to sort this way, and so I give it the strategy, I'm done. And I sort it, and I'm done with it, right? So one is the rate of change of the object, right? The state pattern, you expect, the whole point of it, you're going to change that state object from one state to another. Um, you could change the strategy, but normally you don't, right? So that's one big difference.
Your question, but adding we can make
In the visitor pattern, right? What do we need to do to create a new visitor? Well, you just implement the visitor class, and you have to visit A, visit B, visit C, visit D, right? But now, what if we want to add um, if we want to add a new expression to our expression tree, right? Now, what happens to all of it? Now we have to go back and modify every visitor we wrote, right? Because they don't know about that particular, right? Yeah, so the visitor pattern, it makes it easy to add new visitors, but when you extend the structures on, then you have to go back and find every visitor and
grab back the pattern in general.
yeah,
If your grammar changes, then you have to go back and overhaul.
right.
So it shouldn't be used in a context where you think like elements of the structure you're traversing are going to change.
Right. I mean, so yeah, if, it, if the elements of the structure are going to change, you're going to add them frequently, then the visitor pattern becomes less desirable.
Adding pre-element classes is hard.
Right.
There.
Right there. Yes, I occasionally do that. I go, let's find an important sentence in the book, and then
um, talked about single very briefly.
We haven't covered singleton yet.
No object. Which one you say were the patterns that use coupling?
That explicitly reduce coupling among classes. Well, the iterator for one, right? Because now to go through the elements of that structure, you don't need to know about the internal structure, right? Well, but your question was patterns that reduce coupling, right? And so I wouldn't say that the visitor pattern reduces coupling. It, it helps maintain the cohesion of the original structure. Yeah, some of the other patterns that reduce coupling, like chain responsibility and the wrapper we haven't talked about yet. Coupling between what and what? But that's not. But he asked about coupling between classes, right? So yeah, it means we don't have to worry about subclassing, but
It does. You want to decouple. I guess it's an algorithm. Use strategy. Algorithm.
class. Yeah, but that's true. But if we're talking about decoupling classes, right?
Well,
Right. But same thing with the strategy pattern, right? There's an interface that you.
That's on the algorithm. Interpreter.
Well, but yeah, the visitor pattern, you've got multiple classes, and we're talking about the interface, but in the strategy pattern, right, the class that uses it is coupled to the interface.
What is strategy pattern? Because I feel like I could make the case that it has no effect, or I could make the case that, in the sense that it has no effect at all, the object, like in the case of our priority, accepting it's still doing it, just doing it. But you could also argue that this pattern enhances them by making it more flexible, more tailored to actual implementation use case. So yeah.
Well, you have to keep in mind, cohesion doesn't talk about flexibility, right?
Right. It talks about how well and to what extent the objects and data inside of the objects pertain to what it's supposed to do.
Right. Right. So if we have a priority queue built just to hold students, right?
Right.
That's probably as cohesive as a generic priority queue, but it's not very flexible or usable, right? So yeah, does it really affect the cohesiveness of that class?
No, because flexibility isn't cohesiveness.
Right.
But I mean, the strategy pattern definitely improves the priority queue. It just
Right.
doesn't improve the cohesion
Yeah.
of the priority queue.
Right.
Because it doesn't affect the priority queue's ability to do its job. It just kind of still need function prioritize. It doesn't extend.
You're just making the class useful.
But you're not. Yeah, you're not like you're not fine tuning its definition. You're pulling stuff out that doesn't matter. Just okay.
Right.
Okay. Yeah. So assignment use of the command pattern.
Mm-hmm.
Sort of store the states
Right.
for each. Would have implemented using this value. So, what are the advantages of design? One pattern.
So the reason we use one in one assignment and the other in the other assignment is just to have experience doing both, right? The strength and drawbacks, I think, are fairly clear. To use the command pattern for undo, the operation needs to be reversible, right? And not all operations are reversible. And the turtle example, I mean, yeah, we could have used the command to, because they're all reversible, right? But a move, how do you reverse a move? Well, you just go the other direction. How do you reverse a turn? You just turn the other way, right? So if the operations are reversible, then the command works. Memento, one of its drawbacks is that state can accumulate pretty fast, right? In the turtle case, there's not much state to worry about, right? So it's not so bad. It's probably not much worse than the command because the command needs the turtle and it needs the data to undo the operation.
It's just one state. You just have a list of states necessarily got there.
I think both patterns are pretty simple. The memento pattern is pretty, I mean, it's just basically a struct with here's the data in it, right? So the question is about user defaults. So you get an application, in your case iOS, right, or Android, where they built in a way of saving some state of the object, right? The other situation is you need to save it just once, right? We don't need a history, right? And if you save it a second time, the first value goes away. Yeah. Yeah, but you're not going to use user defaults to save a history of change of an object. It's just too complicated because then the keys have to change, right? And then you need some sort of crazy naming convention, and then it becomes hard to find the right one. So yeah, making the user defaults keep a history is going to be painful. But I mean, the basic idea, right, is the same. Is I have some state of the object, I'm going to save it. But usually the user defaults is not, we're not saving the entire state. It's just there's certain things we want to save because we need them later. Yeah, it's like, why is that there?
Is that caused by error or like an error? Like, kind of like building and all.
You tell me. Why did you do it, right? Um, no. Classic example is the application starts up and you need to read all the user defaults, right? And then you need to, you know, show the initial view and you need to create the controller for it and you create the view for it. So all these things have to happen now, right? At the same time. And so we could write, one function that, reads user defaults and creates this view and creates this controller and connects them all together, then creates another, and then connects a database and does all these things because that's what the application needs to do on startup.
So basically, startup same
The goals and and the content of all the GUI elements and to right. Say that again. Right. Yes.
Is it because like the permission?
Well, so the question is about the visitor pattern, right? And so the issue becomes, okay, I build this structure, in this case, our, our FX syntax tree or parse, whatever you want to call it. And now I'm going to build a visitor pattern because I know in the future I need to add more functionality. I don't know what the functionality is, right? So next week I'll do, distance visitor, and a month later I'll do some other visitor, and a month later I'll do some other visitor, but I have no idea what that visitor is going to do, right? We have no idea because it's going to happen in the future. Now, what happens if one of those visitors in the future, right, needs some data that from our structure that we didn't know the visitor really needed, right? Oh, now do we go back and modify the structure to add another method so this particular visitor, right, can actually access that thing? Oh, but that sort of violates the whole point of the visitor pattern, right? So that's why they say, oh, it may violate encapsulation, but we then, oh, in the Java world, you just say, well, we can, I don't know, put the turtle class with a visitor class in the same package, and that gives it more access rights to the structure because we don't know in advance everything that a visitor in the future will need from our structure, right? Well, the question is the visitor pattern, the statement of the visitor pattern may violate encapsulation, right? And the problem is we don't know in advance what visitor we would need, right? In your assignment, I should have given you assignment, say, do number one, and when you've done number one, I'll give you part two, right? Because then you wouldn't know what the visitor needed, right? But since you knew what the visitor needed, you start doing things like this. But what happens, right? If I would have done that, right? 1 week here you do problem one, week one you do problem one, week two you do problem two, and week three you do problem three. What happens if one of those visitors needed something from the structure that you didn't plan on? What do you do? And that's what they're talking about. Okay, last question.
Really quick, I actually remember when you said procedural confusion, like why that happens. I believe more almost program writers rather than class.
Right.
And for logical, when you say that activities outside the module, just have like command. Like, I'm sorry, I don't know.
Can you?
Quick example.
What's that?
Quick example.
A quick example of logical cohesion. I'm drawing a blank.
I don't want that to be me on test.
What's that?
I don't want that to be me on test. Logical.
What did the slide say about logical cohesion?
Modular objects, elements are similar. The activities outside.
It gives you motivation to get the paper and read it.